Okay, we are now in Module 10. Okay, Module 10 is called Generating Equivalent Expressions. In Module 9, you were generating equivalent numerical expressions. In Module 10, we're going to work with algebraic expressions, okay? That's how you say that word, algebraic. Equivalent algebraic expressions. So let's get started with lesson 10.1, where our goal is to write algebraic expressions. So you are going to learn how to take words and write algebraic expressions from the words. Okay, so first we have to figure out what algebraic expressions actually are. All right, so let's take some notes. First of all, let's do some vocabulary. What is an algebraic expression? Okay, an algebraic expression. You know what a numeric expression is from Module 9. An algebraic expression is also an expression, but it is an expression that contains one or more variables. Okay? Numeric expressions had numbers and operations, but no equal sign. Algebraic expressions have numbers and operations, but also at least one variable. Still no equal sign though, okay? Still no equal sign. So we can't solve an algebraic expression, but we can simplify it, right? So a variable, let's talk about what a variable is. So if all algebraic expressions have at least one variable, what is a variable? A variable is a letter or symbol that is used to represent an unknown number, okay? The value of a variable can change. So when we don't know a certain number, it's missing or unknown, we put a letter in its place. Now, we also have in algebraic expressions something called a constant. A constant is a specific number, and constants do not change. Okay, so if you have a constant, it is a specific number, and the value of that number does not change. Whereas variables, the value can change. Constants, the value does not change. So algebraic expressions have numbers called constants that do not change. They also have operations, just like numeric expressions, but they also include at least one variable. It's a missing or unknown number that we put a letter in place of the number. The letter will stand for some number that we don't know yet, okay? So here are some examples of algebraic expressions. You might have something like x minus 3, okay? So some number that we don't know minus 3. You might have 4x minus 2, okay? So that is 4 x's minus 2. Or you could have something like x plus y plus z, and then we have 3 unknown numbers, okay? There's 3 letters there. All of them stand for some number that we don't know, some specific value that we don't know, okay? And it's x and y and z because it would be 3 different numbers, okay? So in an algebraic expression, when we write the operations, multiplication and division are usually written without these symbols, x and divided by. We're no longer going to use those. When we start writing algebraic expressions, we do not use this to mean multiplication anymore because it looks too much like the letter x. And now that we're going to have letters in our expressions, we can't use this to mean multiply anymore, because how can you tell if that means multiply or if it's a variable, right? We also don't use the division symbol anymore. So let me show you how we write multiplication in an algebraic expression, and then I'll show you how we write division in an algebraic expression. So starting with multiplication, we do not write 3 times n. We don't do it that way. That's no, okay? What we do write is 3n 3 ends, right? This means you have 3 ends. If that's a number, like let's say that's number 2, and you have 3 of them, that's 3 times 2, right? Or 3 2 times, or 2 3 times. So you just put a number right in front of the letter to tell you how many of those you have. So you have 3 n's here. That basically means 3 times n. You can also write it in a parentheses like this. Anytime you see a number right up next to a parentheses, that means multiplication. You're multiplying that number times whatever is inside the parentheses. You also might see it written with a dot. The dot is less common, but you do see that, okay? But you will no longer see this symbol that looks like an X to mean multiplication because it looks too much like a letter, okay? And now with algebraic expressions, you're going to have letters in the expression, and they need to look like letters and mean that they're letters, right? So let's talk about division. Division is written one way now. We are no longer going to see this. 3 divided by n. That's not going to happen anymore. What you're going to see is 3 divided by n. I have been telling you all school year that a fraction is just a division problem. This says 3 divided by n, all right? And that's how you'll see division from now on. So this is the most popular way you'll see multiplication, right here and also here. This is how you'll see division, 3 divided by n. All right, so we are going to, this whole lesson is about writing algebraic expressions. So when you do your practice, it's going to be asking you to write algebraic expressions from words or from situations, okay? So this is a list of words that you might see, and it'll help you to look at this to know what operation they're talking about. If you see added to or plus or sum or more than, that's going to probably be addition. There are other words that could mean addition. This is just some of the words. Here are some words that mean subtraction. Subtracted from, minus, difference, less than. If you see those words, you're talking about subtraction. Multiplication could be times, multiplied by, product, group of. The word of often means multiplication. Division, divided by, divided into, quotient. Those are all division words. Now, there are other words for all of these, but this is just some of the words you might see. And you're going to be practicing taking words and writing algebraic expressions, okay? So here are a couple examples. Down here below, it says, write each phrase as an algebraic expression. The first phrase is the sum of 7 and x. So the first thing you want to do is figure out what is the operation. You see the word sum there, and you see the word sum there under addition. So the operation is addition, right? And so the algebraic expression would be 7 plus x, okay? So what you're going to be doing in your practice is taking the words and writing an algebraic expression from the words. All right, here's another one. It says the quotient of z and 3. So you look here, you see quotient is under division. So you know this is a division problem. And the algebraic expression is z divided by 3. Z divided by 3. Okay, when you see the quotient of z and 3, z is divided by 3. That is when you have phrases. And now let's do some where there's actually a situation, okay, where it's like a story problem, okay? So this is called expressions for real world situations. So let's look at this. The tickets to the water park costs $53 per person. Write an expression to show the total cost of tickets for a group of people. Here are some steps to taking a situation and putting it into an algebraic expression. Now remember, expressions do not have an equal sign. So we are not writing an equation. We are just writing an expression to stand for the total cost of tickets for a group of people, okay? So the first step is to identify keywords and phrases in the problem. So per person is a key phrase. that word per means something in math, okay? Per usually means either multiply or divide. How can I tell if it means multiply or divide if it can mean either one? Well, the next key word we have here is total. If we're looking for a total, we're looking for a larger value, right? We're looking for a larger value. Okay, so that means if we're looking for a larger value, we're probably going to be multiplying. Okay, when you divide, you actually cut the up into smaller pieces, so you get a smaller value. When you want a larger value with the word per, you're going to multiply. Okay, these are the kinds of things you want to keep in mind. Then the next step says identify any constants. Well, right there, 53 is a constant. Constant is 53. That means 53 doesn't change. It's always $53 for each person. It's not 10, it's not 52, it's not 9, or it's always 53. It's constant. That's not going to change. Then what you want to know is what is missing. What is it that we don't know? Well, we don't know how many people are in the group, do we? It just says write an expression to show the total cost of tickets for a group of people. It's $53 for one person. How do we know what the total is if we don't know how many people there are, right? So then we're going to let the variable stand for the missing number. So let's do P stands for people. How many people? How many in the group? So we don't know, right? We don't know how many people are in the group. That's a question mark. Okay, we don't know how many people are in the group, so we put a letter there because we don't know that number. Now, can we write an expression with the constant 53 and the letter P that will give us the total amount of money that it's going to cost for the group? The group has P number of people in it. Well, 53 multiplied times P is going to give you the total cost. So if there's one person, 53 times 1 is going to cost you $53. If there's two people, 53 times 2 is 106. It's going to be a total of $106. If it's three people, right, it's going to be $59. So for every person, it's going to be another $53. So basically, this number P stands for the number of people. And if you multiply that number times 53, you'll get the total cost for that many people. Okay, so this expression right here stands for the total cost for a group of people. And whatever the group number is, you put in place of the P. Okay, that expression means total for the group. All right, let's try one more and then you can get to your practice. This says, Janice has some savings. After babysitting, she adds $75 to her savings. How much total has she saved? So we're going to write an expression that stands for the total that she has saved. So we're going to do the same steps. Keywords. Well, add, that's a keyword. And again, total is a keyword. So we know we're adding. I mean, it says right there, add, right? What is the constant? 75 is the constant right there. That's how much that she added. That we know that. And what is missing? Okay, we don't know how much she started with. So we know she's adding $75, but we don't know what we're adding it to. So the missing number is the starting number. The starting number she already had in the savings. It just said she had some savings, but we don't know how much. So let's let S stand for the savings that she started with. Okay. And we know we're going to add $75 to that. So if we take S and we add 75, that expression right there, S plus 75, stands for the total amount she has in her savings. Okay, so this expression, we don't know what that equals, right? It's not an equation, it's just an expression. This expression stands for the total amount she has in savings, okay? So all you are doing in this lesson is writing expressions, figuring out what the words mean, either in a situation or in an expression like z plus 9, right? Or z added to 9, when you're going to take those words and you're going to write expressions. So this is the expression, this would be the answer to this problem, and this is an expression, this would be the answer to the second problem. Okay, writing expressions. In your learn and do today, it's broken down into must do, should do, and aspire to. These are the two that you must do. You must do IXL Y1, and you must do the HMH for 10.1. Now you should do this IXL and this paper pencil as well. And if you really, really want to do a higher level, then you'll also aspire to do this next Y2 write variable expressions with 2 operations. We're just working with 1 operation is the required level. But if you really want a challenge, you can try the 2 operations, okay? But these 2 you must do. These you should do, but these you have to do, okay? Lesson 10.1.